Okay, so for these ones, multiplying, and we're going to use a multiplying to simplify. So I guess we can make it as 1/3. So another way they might ask you a type of question like this is make as 1/3. 7 times 3 is 21. So that's really just putting it as 1/3, square root 21. We don't know what that, well, we can't give it, it's irrational, so we can't actually solve it further than that. That's the tidiest way to do that and simpler than what we had. Next one there, square root 60. 60 is a bit of a big number, so I'm going to look for factors that potentially I could take out to make it simpler. So 60, 4 times 15, right? 6 times 10. The 4 gives us a clean square number, so we can do that. So square root 60 is equivalent to square root 4 times 15, which is square root 4 by square root 15. Square root 4 is 2, square root 15 irrational, so we can write it like that. Now, we've gone and taken something out of the bracket, but there's no plus in between. There's kind of like a times. So that is a simplified version where we have a clean component and then a component inside the surd sign. So that's all good. Okay, for this set here, it's also simplifying. They're pretty simple in a way, you might say. So when we look at these particular numbers, we cannot find square root 2. It's irrational, or square root 7. But we have this times sign, and in a way we also have times between the intermediary terms. So that means that we have 5 times square root 2, like that. There's a times in there. And there's a times in there, times 3 times square root 7. So what we're allowed to do in that instance is we take the numbers out and multiply them, 5 times 3, and also keep the surds together like that. So a little bit of rearranging, simplifying, and that one there becomes 2 7s are 14. So altogether 15 square root 14. Is this simpler than when we started with this? Yep. We've got one term instead of two. We have one clean number outside the surd sign and one inside the surd sign. Here it was kind of expanded, so we've just really regrouped the 5 and the 3 and the 2 square root 7. Okay, let's do B. B is 2 times square root 5 times square root 5. It'd be tempting to do all sorts of things here, but if we look at square root 5 times square root 5, we would put that inside one surd sign as square root 25 times 2. Square root 25 is actually just 5. So that one reduces down to 10. So that's really nice that that whole thing equals 10. Last one here, we have the 3's are the whole number part. So we can go 7 3's are 21. And inside the bracket, we can put the 2 in the, not bracket, surd sign, 2 and 6. So we have 21 square root 12. 12 is made up of 3 and 4, which means we can pull the 4 part outside of the surd because 4 is a square number. So 21 times square root 4 times square root 3. Square root 4 is 2. So very simply there, 21 times 2, and still times by square root 3, which we can't do too much with. So altogether, 42 square root 3. Last set, I think let's just have fun with these and play with them. So let's do A first. So A is asking us to expand and simplify. So we're expanding the thing outside the bracket by each of the terms inside the bracket. So if you can expand plain numbers and simplify surds, you're doing this all together. So we're going to times this by that, and then by that, and then by that. There's 3 terms inside the bracket. So let's just expand that all out first. 3 square root 2 times 5 square root 3 plus 3 square root 2 times square root 2 minus 3 square root 2 times 2. So I'm going to take the second line to tidy up each of those 3 terms and see if we can't do anything with it. This one here, 15 square root 6 plus, now square root 2 times square root 2 is just 2. So let's put that on the third line of working. 3 times square root 4, sorry, so it's just 2. So that second term reduces down to become plus 6. Okay, and now let's work this third term down the rows too. 3 2s is 6 times square root 2. I'm just going to bring that down. It's a bit of a messy old thing, but we've done what they asked us to. So in some ways it was simple in a bracket, really, with some common factors out. I can't see common factors in here. I can see the 6 there, but then I'll be putting these two terms back into a bracket if I pulled out the 6, if I took that as a common factor. So I'm just going to leave that. That's all they're looking for there, and let's do part B now. So part B is a double bracket. So we're going to use FOIL. So we're going to do firsts, outers, inners, and lasts. Fun times. Okay, so let's go for it. So square root 3 times 2 times square root 3. I'm just bunching them together. And then this with the outers, minus 5 times square root 3. And now the inners, which is a plus 4 lots of 2 times square root 3, and then the last minus 4 5s are 20. So let's do some tidy up action here. First term, it was a whole 2, and 3 3s is square root 9. Nice. And the next one is 5 square root 3, and 8 square root 3 minus 20. So tidying that through, that's 2 times 3 is 6, minus 5 square root 3 plus 8 square root 3, take 20. So looking at what we've got here with the expanded terms, we can still do some tidy ups here. So first thing that you should notice is that there's a 6 and a 20, so they're like terms, so we can simply make that minus 14. And then when you look at the middle two terms, we have 8 square root 3's here, take 5 square root 3's here, so plus 3 square root 3's there. So we have two simplified terms there, and the way to deal with those now is just, we really want to leave them alone. Starting off with a minus isn't too pretty, so we're going to subtract it away. So we're just going to switch the terms around, just swap them. So that's our final answer here. So now for part C, we also have a double bracket term, a binomial, that we can expand. Okay, so firsts, outers, inners, lasts. 1 2 3 4. Okay, so let's do the first. So that's 2 square root 2 multiplied by 2 square root 2. And the next term, which is our outers, is plus in between. 2 square root 2 multiplied by square root 3. And then the inner terms, which is part 3, is there's a takeaway sign in front of the square root 3, which gets multiplied by 2 square root 2. I'm putting dots in between because that's a symbol for times. It's a convention that I'm just going to use now because it's going to help me. And my very last term is also a minus square root 3 by square root 3. So what I've done now is I've just FOILed it. I've expanded that double bracket, that binomial, and now I'm going to go through and tidy everything up. So what I'm actually tidying up is 4 terms, and see if we can use our surd rules to get those looking a little bit tidier. So 2 times 2, we've got the number parts here, is 4 by square root 2 times square root 2. So that entire term, square root 2 by square root 2 is square root 4 times 4 is 4 by 2. So that first term becomes 8. The next term is 2 3's is square root 6 minus, I've got a 2 number here, and a 3 times 2, which is also a square root 6. And then at the end, I have minus square root 9, 3 by 3. And so that one there becomes minus 3. Now, this one here, I just want you to have a look at it. We have positive 2 square root 6, take away 2 square root 6. So those are cancelling each other out. So that one there is like a plus 0. Okay, so that's what's happened there. And if we now take the last step, 8 take 3 is 5. That's our final answer. In the worked example in the actual textbook, this is what they do for that one. They begin solving it by using the difference of squares. So when you have a minus b multiplied by a plus b, that is the same as a squared minus b squared. So that was one of the rules that we looked at when we did polynomials, and that's why they cut straight to the chase. So the a term was 2 square root 2, and the b term, and then they just changed colour there, they just squared that. And then the b term was the second term in the brackets, which is just square root 3, all squared. So that essentially cuts out the guts, or this green, the two middle terms that we expanded out fully. But I just expanded this out, not paying homage or respect to this rule, but either way will work. So I just showed you that why it works out the same, and this particular rule here is the difference of two squares, which is quite important. I will just work that through for you. So if we square the first term, that becomes that squared, okay? So 4, square root 2 times square root 2 is square root 4. So that becomes 4 times 2, which is 8. And the second part is square root 3 all squared, so it's square root 3 times square root 3, which is square root 9, which is 3. 8 take 3, also equal to 5. So that's the way the textbook does it here.